So I just ordered.
Huh?
Do you accept IOU?
Yes.
Why is this recording? Are you recording the screen?
Yeah. I always record the screen.
Do you accept IOUs?
You have a hard bargain.
Is that a yes?
No.
No? Like, what about super honest?
Do you really need to give me an IOU?
Wait, it doesn't pick up audio from the outside, right? When you record the screen?
Yeah, it records. It probably hears you right now.
Oh, yeah. So then you post it on the feed, give it to people, like, so they can, people who can make it.
It's on YouTube. I email the links. Okay, we're gonna get started, everyone. I'd like to finish, hopefully, at least the first 7 or so before the pizza gets here. Okay, so for number 1, we're integrating from 2 to 5 of 2 over 3x plus 1 dx. And as you might suspect, this is going to be a u substitution. So my u is going to be equal to 3x plus 1. Du is going to be 3 dx. Whoa, what just happened? 3 dx. And that's going to turn this into, and basically what's going to happen is I'm going to now take these upper and lower limits and we're going to kind of ignore them for now because we just want to look at the antiderivative. So we're going to try and get this antiderivative. Yeah. You're right, du over 3. That's going to be 2 over u times du over 3. All right, so that is 2/3 antiderivative of du over u, which is equal to 2/3 natural log of the absolute value of u plus constant. So we made a lot of talk about that natural log, and remember that every time your antiderivative is a natural log, you have to put those absolute value signs there. Okay. Or at least you need to know about those absolute value signs. So we get 2/3 the natural log of 3x plus 1. And we integrated from 2 to 5. And now you just substitute. 2/3 of the natural log of, let's see, 16 minus 2/3 the natural log of, let's see, 7. You're going to use properties of logs. And the property that we're going to be using is the natural log of a minus the natural log of b equals the natural log of a over b. We're going to use that right now to say that this is equal to 2/3 the natural log of 16 over 7. That takes care of number 1. Remember this review sheet being deceptively short. Or is it deceptively long? Wait, if it's short but it's really long, is that deceptively short or deceptively long?
Deceptively short.
This is deceptively short. Question 2. We're integrating 2x over root x squared plus 1. This is very nice. U is going to be equal to x squared plus 1 because that's going to be that's the inside of the square root. Du is equal to 2x dx, which is a good thing because this 2x dx, we have the 2x there and the dx there. So both of those underlined things are going to be traded for a du. So that's going to be equal to the antiderivative of du over u to the 1/2 power, which you can simplify as antiderivative of u to the negative 1/2 du. Using the general power rule, 1/2 plus 1 is, negative 1/2 plus 1 is 1/2 positive. Reciprocal is 2. So 2 u to the 1/2 plus constant, which equals 2 square root x squared plus 1 plus constant. Yes, you are correct. Gas it. Question 3. Integral of x cosine of 2x dx.
There's supposed to be 2 C's here in the
Huh? Where?
There's 2 to the 1/2 plus, just kidding. No.
Meow. Okay, so the question 3. It kind of looks like we could use this u substitution, right? So if u equals 2x, du would be equal to 2 dx, but there's still this x here. Okay. So it looks like we're going to have to use the or integral by parts. Okay, integral by parts. This also, because my u is going to be equal to the x, this is also a perfect candidate for a tabular method. Okay. So remember, don't start off with the tabular method. Start off by asking, is this going to be a u substitution? If it's not going to be a u substitution, it's going to be a tabular method. Now that you know it's a tabular method, now that you know it's not going to be a u substitution, you're going to go to the integral by parts. Once you've decided on integral by parts, now you have to decide if it's a candidate for use for a tabular method. And this is because the u is going to be the algebraic part. Okay, derivative is 1, antiderivative 1/2 sine 2x. You know what's nice about this is once you get here, all of a sudden you get really fast at these integrals, huh? You have to. Derivative of 1 is 0. This becomes negative 1/4 cosine 2x. Great. And then positive 1/2 x sine 2x minus negative 1/4 cosine 2x plus constant. Okay, it looks like I can factor out a 1/4, right? 1/4 2x sine 2x. Thank you. Plus cosine 2x plus constant. Oh, hey, the answer didn't factor out the 1/4. I said if this is multiple choice, you're going to have to be able to recognize the answer regardless of whether or not you factor. Personally, I prefer that you factor. Question 4. X squared e to the 3x. All right, before you go right to the tabular, is there a way I can use a U substitution? Okay. Good. No. Remember, don't go right to the integral by parts. It's not correct to start off assuming the integral by parts.
If you do integral by parts and you can also do U substitution, would that be a wrong answer?
I'd be very worried. It's usually one or the other. Usually one or the other. Okay, so we got x squared e to the 3x. Oh wait, what did I do there?
Yeah, you're right.
Right, 2x. Is this 1/3 or 3? 1/3. 2 1/9 e to the 3x. 0 1/27 e to the 3x. One at a time. This equals 1/3 x squared e to the 3x minus 2/9 x e to the 3x plus 2/27 e to the 3x plus constant. Looks like I have to factor out 1/27, right? So 1/27 e to the 3x. I think that's pizza.
Can I go get it?
Hello? Hi, this is he. Okay, I'm sending someone down there right now. In the parking lot. Okay, can you come right to the stairs? Or they'll find you. Okay, thank you. Outside. He said he's in the parking lot.
Okay.
Let's finish this. Finish. Okay, we got x squared. No. 9x squared. Plus. No, minus 6x. Plus 2. Plus constant. Yeah.
Is that the answer?
That is the answer.
Then why did yeah,
Why does it have a what?
in the back or at the bottom is a really weird answer.
Let me look at it.
I was thinking that, yeah, that was
It's the same answer, it's just different. It's differently simplified.
Oh, yeah, it's the same thing. Just didn't factor out 1/27.
I didn't choose.
I don't know why I factored out 1/3. All right, last one. Last one, 5. And for 5, really the words general power rule are only there to confuse you? Well, it worked. And I'll show you where the general power rule is. Okay? U equals 4 minus 9x squared du equals negative 18x dx. We have an x. We have a dx. We don't need the 18. So x dx equals negative 1/18 du. So the underlined portions are going to turn into 1/18 du. This becomes the antiderivative of root u times negative 1/18 du. I'm going to rewrite that. Negative 1/18 integral of u to the 1/2 du. Now I'm going to integrate. That's negative 1/18 times 3/2. No. 2/3. 18th. 2/3 u to the 3/2 power plus constant. This right here is the general power rule. That's where the general power rule happened. You were using it, you didn't even know it.
Totally murdered your signature, but it's fine.
No, it's okay. Thank you. What is that? Negative 1/27? Square root of 4 minus 9x squared cubed plus constant. It looks like the plus sign didn't make it.
You left 3/2, so they're also cubed like that also.
It's going to be part of a. I feel like I've said this a couple times. It's going to be part of a multiple choice.
Determining one of the answers there or not.
Okay. All right. Pizza time. Time. Save me 2 slices.